Hey, this is Steven from LegitTechTutorials, and welcome back to my product development series. We're back working on the Wi-Fi RC plane receiver. 1 second, let me start my stopwatch. So my RC plane receiver that will control multiple different configurations using the ESP8266 over Wi-Fi. Control it using your phone. So again, we're finishing this guy up to get ready for the event in... which reminds me, I probably should buy one of those mini servos already, because I don't have one. And the event is the 27th, so it's about, starts on Wednesday or so. So I would definitely need, and today's Friday, so I'm going to have to get something from Amazon. Those servos, or buy it down at the store, but those are like 12 bucks, 12, 13 bucks down at Aero Micro. So I could get either a linear servo or an actual rotating servo like that. I'm kind of leaning more towards the linear servo. I mean, but they're both pretty similar. Anyways, a little micro servo. So, we are continuing working on the schematic before I go on to the event. I already got my schedule. I'm going to be on the flight line at Flight Fest 2017 West. And then we will be soldering it together at the event, because I'll have some time at the event, because I'm only doing one shift. My shift starts at 7:45 or something like that and ends at 10. And then the rest of the day just hang out and work on projects such as this for Wednesday, Thursday, Friday, Saturday, Sunday. Anyways, yeah, so I'm going to have some time during the event, so what I need is to finish the schematic and any sort of other electronics that I need that are not in this bag right here. Also, last week I received my programmer, so now I have my my programmer. I think it was a C120-102 or something, CP102 FTDI to USB programmer. It's not particularly built for the ESP, but you could wire it up to where it works for the ESP. But you have to do a special sort of breadboard layout to put the ESP8266 into program mode. So I'm also going to have to do that. And yeah, also I looked a little bit, I looked up some information on the P-type P-type transistor, and I can't remember if that requires a positive. I think requires either a positive or a negative signal. So basically what it is it's determined by which side of the load you're on. So if you're on the high side or the low side, so if you're on the high potential side or after everything is dropped, and you're basically so are you connecting positive to positive, or are you connecting negative to negative? And then the other thing is the signal that is required to toggle it on and off. And I believe with PWM, the cycle rate is basically if it's negative, but see, that's the thing, is that I don't know if it's negative or just ground signal, because obviously ground signal is not very safe. So let's go ahead and duplicate this. Okay, so let's go ahead and do some so here's a transistor. So this is an NPN, so this is, I believe, an N-type. So which one is there by again? I bought MJ something. This is P&P. So this is NPN. So this is opposite. So you see here VCC, V out. So this is close to ground. So this one is opposite. The NPN is switching of ground, so it's negative, positive.
So it's on the negative side, and then the PNP is on the positive side. Let me see if they have. So yes, you see here positive, and then here, yeah. So, and then these are FETs, E channel, N channel. So you see positive in here, positive through. That's pretty funny. So we're looking at the PNP. So yeah, you see here, featured like an open circuit with broken connection. So it's not really the correct type is the main issue right now. Because as you see here, when the gate is supplied with 0 volts, we have a closed circuit like a wire between the source and the drain, which basically means that when it is 0 volts or grounded, the circuit is closed and letting power through. But when the circuit, so when the circuit is closed, it lets all the power through, and then when it's above 2.9 volts or whatever this would be for my particular power switch, then it will be opened. So that option is flipped of the N style, where the N style would be on the negative side, and it would take a positive. So when it's 2.9, it's closed, and when it's 0, it's open. Right? So we can go here and type. See, when it's high, it's closed. When the connection between the source and the drain is broken, we say it's an open circuit. This happens when the gate is supplied with 0 volts. Alright, so let me check out instructables. So yeah, so I should be correct here. The issue is what I'll have to do is basically reverse the PWM cycle, where what it does is instead of alternating the highs, it alternates the lows. So I believe at the current situation, basically what it would be is it would be reversed. So when you increase the PWM cycle, you have less lows, and so it's less open. But when you decrease it, it goes fast. The highs are low, and the highs are less frequent, and the lows are the grounds are more frequent. So that would mean that the gate would open at that point more, because basically a PWM signal is a square wave, right? And then the PWM is actually pulse width modulation, and basically what it is the frequency between highs is what you're setting. And when you have the frequency between the highs higher, when you're sending a higher PWM signal, it is supposed to, in this case, if we used an NPN, it would cycle the motor faster, so the motor would take more power and go faster, spin faster. However, with a PNP, or a P channel, what would happen is that on the lows, the motor would go faster. So as you lowered the cycle speed, the motor would go faster. So kind of counterintuitive. So maybe what I could do is in the software itself, just flip it around. Okay, so let's go ahead and double check. We'll add these two resistors here, and then we'll add my diode. And this guy, oh, I didn't load this to the schematic. There it is. Yeah, so here it's got a 270 ohm for the for where the PWM comes in. So, and also what you'll notice here is that they're using, I might show you guys this video here. I just watched through it. It's pretty cool. But in that video, he's using of cars ESC, a pre-built ESC, which is obviously what we're trying to build to get away from the costs. So, yeah. Okay, we're going here, and then we're looking for the diode. Oh yeah, the diode's over here. So here's the motor. You only want the diode to go. So we're gonna put this on there, and then see, and then make sure that the that it's going the right way. So if it's not going the right way, then it's kind of hard to see. It's kind of hard to see in this one, like how it's attached. But here's the high. So it's going opposite of the high. So when the high comes in, make sure the high only goes to the low, which basically would mean that I want so let's say this, and then this guy should be only going in this direction. So let's just say that it has to go from here. I think it's this way. Not quite sure. Okay, maybe it's the other way then. So what I'm going to do is take this guy, there we go. So that's the right way. Alright, so now that should only let the current go through here, not let any of the EMF come back through here or generate any current to destroy the PNP, the transistor. Okay, also another thing that's pretty cool is it shows the RPM, which is pretty cool. Actually, it's spinning a lot faster than it was before. That's pretty weird. Anyways, okay, so that is one part, and then the final thing that we need to add is some of these, because what I'm going to assume is that those pieces are already inside the the ESC of this one. Okay, so PS6, GPIO 0, the 1K goes up to there, and the top of C2. So let's go into this resistor. This is a 2K, 2K, oh, excuse me, R1, the other one's also 2K, 2K, oops. Okay, so now those guys go into the breadboard where they attach to GPIO2. This first one's GPIO2 to the top of C2. GPIO2 to the positive C2. GPIO2. Huh. It's actually, one of these is R4. Just make this one R4. Okay, so from R4, GPIO2, positive C2. R4, and then also to the positive of C2. Like that. Okay. Finally, R1 goes from GPIO 0 to C2. GPIO 0, oops. CPO2. Okay. So that is looking pretty good. So here is the here is this guy. Very freaking difficult to read. Okay, well, I mean, that makes sense, pretty much. Here, positive. And then this all depends on, of course, what direction you want the motor to turn. Oh, man, these are really ugly looking. Okay, there we go. And here's the battery. Okay, so I like that. And then this guy... Okay, that's a little bit easier to see. So, alright, so let's trace it. Positive in, out. Where's my ground? I mean, that's basically the ground there, but, okay, then here the ground, everything should be pretty much attached to the ground for the most part. But why is this not attached to a ground? Anyways, positive goes through, positive goes straight to the servo, supplies the servo, ground comes right back through into the negative ground from the servo, signal, that's not right. Which one's supposed to be the signal? GPIO2. Oh. Then yeah, I guess that's correct. This ground is supposed to be straight to the battery. Oh, it's straight to the battery here.
So yeah, there's a few, and this looks like it's correct.
Looks like it's correct. So, but I'll do some more investigation on this, and I'll change it and do an update video at the event to show you guys how it's going. Alright, so another thing that I wanted to look at is just talk a little bit about the code here, because this is what I'm going to be flashing to the ESP8266, pretty much exact from what this is. So of course you're going to have to install RoboRemo onto your phone for right now. I'm going to be using RoboRemo. Install it on your phone so you can control your car via your plane via your RoboRemo app. 4-channel RC receiver for controlling an RC car, boat, plane, quadcopter using ESP8266 and an Android phone with RoboRemo app. Don't use RoboRemo for live support, blah blah blah. So here it's the ESP8266, Wi-Fi.h, using it as a Wi-Fi client, and servo.h. Constant character SSID, my Wi-Fi. So this is basically the SSID that the ESP is going to broadcast through whichever type of setup it's using. 802.11a, b, or c, I think it has. So it's going to broadcast my Wi-Fi, and then constant character password, the password for that particular Wi-Fi. Then this is the IP address and the subnet mask that it's going to use, and also the port that will be open. And then so this is all the stuff you're going to put in your you're basically going to connect this to the Wi-Fi, connect this to your password through your phone, and then on your RoboRemo app you're going to set up the IP, the net mask, and the port number it needs to connect to. And then these are the number of channels. 4-channel, you could add more if you have more GPIOs. Servo counts. This will generate C count. So this basically creates an array of type servo, which has a total number of 4. Int channel pin 0 to 14, 12 ESP. These are basically pin routing. So it goes to GPIO 0 is 0, GPIO 2 is 2, GPIO 14 is 14, GPIO 12 is 12. So these are the corresponding GPIO pins on the ESP. Channel values, these are all set to the middle value, obviously 0, 1500 to 3000. And the minimum pulse width in nanoseconds, microseconds? Is it microseconds? US microseconds. It's mu-s. So it's 10 to the negative 6 microseconds. 10 to the negative 6 max 2300 microseconds. Wi-Fi server port. Port is right there. Wi-Fi client. Initializing the client with name Wi-Fi with name client. Char command stores the command numbers, index, basically last time the command is sent, how long it's been live for. Execute command, and then last command time is basically set to how long the ESP has been on for. So RoboRemo slider ID to channel 0. So when we create the interface, the RoboRemo ID slider, which is our throttle, is going to be ID set to channel 0. So you need to set that, otherwise it doesn't work. Set minimum to 1000 and maximum 2000. And I believe those are the different nanoseconds or microseconds. Basically what it does here, it's attaching that servo channel to the channel pin with the microsecond min and microsecond max, and then here is basically where it writes the position to the servo. And then here, same thing, this is inverted channel, which we're not really going to use. And this is for the movement, left and right, turning this is So actually, sorry, this is not a servo. This is for the motor. So this is what is going to actuate our speed of the motor through our transistor. And then the second setup is the accelerometer that will do the motion. So we can either do an accelerometer that will move the motion, that will move the plane. We'll probably start out with that first, because what we're probably going to do is just build a simple rudder setup. It's just a rudder throttle setup. So this one, using accelerometer, is using the accelerometer of your phone to basically turn left and right a car, but in this case turn left and right the rudder of a plane to move the plane left and right. And then later on we could add it to where it's a it's just a slider instead. So here is all the stuff RoboRemo needs. Again, same thing. So you see them both be channels, transmit. So here's servo channel right, a certain generally for a servo it's rotation, but for the one above that's the cycles per second of that. So in this case it would be, I would be using the invert channel because I have a PNP instead of a NPN. So I will have the inverted channel. So instead of going up, and so when you go up, it's actually going down, so that the ground is becoming more frequent. Here's the setup, attaching the servos to different pins. Begin, software API, IP, net mask. Software AP, access points, SSID, password, a debug line, basically saying what the SSID, the password is, blah blah. Contact lost for more than half seconds. Do detach, stop PWM signals. What it seems like here is it writes the middle value. Sets all of the middle value. 1 second. Alright, so sorry about that. While the client server is available and is not connected, then just if it fails connection, return and do nothing. Client is available and we're connected, then start reading characters, start pulling in commands and adding commands to the command index of the array, and then configure the times. Alright, so that's basically it. It looks like pretty much everything in here we'll be able to use, and we don't really have to modify much. We just have to make sure that it inverts it with our PNP, or I have to go buy an NPN transistor or MOSFET or whatever. But for right now it seems like it should accept the PNP, and now all I have to do is write this to maybe even I'll use one of my maybe I'll even use one of my servos that I have. I bought a whole bunch of servos for maybe the multi-streamer project, so maybe I'll just use one of those. Those are 9 gram, so it's going to add a little bit of weight to the plane, but if I need something smaller, I can buy one of the smaller servos. So with that, I'm going to go ahead and write, later on, write this to the ESP, and then maybe go into the debug line, add a few debug lines, and see that it works remotely while it's still connected up to the computer, that it, that when I send something from my phone, it actually actuates stuff. And maybe that will be another video. And then once I go from there, I can build a circuit on a breadboard, and then do maybe some soldering and maybe put it on a pad board or something, solder everything on there, and try it out. And if it's giving me debug lines and it's telling me how many microseconds it's sending, it should work if my schematic is right. So of course, print out the schematic, have a breadboard there, flash flash through the ESP. Make sure that firmware is working. Make sure that I'm getting debug readings on the computer that I'm using to look at it, and then from there, build the plane. Stick this thing attached to a breadboard onto the plane. Make sure it's protected so that if it hits, it doesn't break anything, and then try to fly it, and then mess with the firmware from there. Alright, so this has been Steven from LegitTechTutorials. I'd like to thank you guys for watching. If you liked the video, please subscribe for more videos like it in this series and other series as well. See you guys in the next video. Thanks for watching. Take it easy. Peace.